So once again, hello and welcome to the videos for Shaughnessy's class. This is Exponents and Logs, lesson number 7. It's talking about solving an exponential equation, a slightly different method, just so you know both. Once again, the standard disclaimer, make sure you show up to class, because we go through it in much more detail there. But let's get going. So this one here, okay? Solving an exponential equation another way. Okay, now we can do it by the conversion from exponent to log form, and in fact that's probably the nicest. However, there's another way to do it, and I just want to make sure you're aware of it. Now remember the equation 3 to the power of x equals 14. Okay, we did that before, and what we did is we did this: 3 to the power of x equals 14. So we said, well, okay, that's an exponential equation, can't do anything that way, but I can convert it to a log equation. The base of the exponent was 3, so the base of the log is going to be 3. The 3 was with the x, it's now going to be with the 14. And the leftover stuff goes out there. I get log base 3 of 14 equals x. I'm done with that. That's the exact form. Then I go through, remember, I turn on my calculator, I go alpha, go into this other menu, the log base 3 of 14, and I get that x is 2.402. Okay, 173,503 ... Now, if you couldn't do it that way with the log base because you had the old calculator, remember that what you typed in is the ordinary log of 14 divided by the ordinary log of 3. Okay, divided by, I missed the divide, so divided by that, and you'd get the same answer. And so we looked at those. Okay, that's how we did it before. There's lots of ways to do it. Okay, that way I like. Okay, what if you can't do that? What if you've only got base 10 logs? This helps the people that have the older calculator, or the older calculators, I guess. Since your calculator uses base 10 logs, take the log base 10 of both sides. Use the log laws that we learned just in the last lesson to simplify and isolate x and solve what's left over. So what this looks like is this: if I have 3 to the power of x equals 14, rather than doing the conversion, I say, well, I can't do anything here, so I'm going to take the log base 10 of both sides. So I'm going to get the log base 10 of 3 to the power of x equals the log base 10 of 14. Okay, I just do the log of both sides, and the reason I can do that is whatever I do to one side I have to do to the other. So since I took the log of one side, I'll take the log of the other. Now, how this is helpful is once I'm comfortable with the log laws, I know that the log of 3 to the power of x, that third law allows me to move that exponent down or back up. So I'm going to bring it back down. So I'm going to get x times the log of 3 equals the log of 14. And I want to solve for x, okay? And x was multiplied by the log of 3. So I've got to undo that multiplication. The opposite of the multiplication is the division. So I'm going to divide by the log of 3. Whatever I do to one side, I do to the other. And so I'm going to end up with x equals the log of 14 divided by the log of 3. There's my solution. Now that, by weird coincidence, is exactly, this is just the same screen, that is exactly what I did back up here to figure out that if I had the old calculator. Okay, back when we didn't have the calculators that could do logs to different bases, this is what we had to do. Okay, we couldn't solve them any other way because we didn't have the ability to evaluate a log to a different base. So we did this. In fact, when I was in school, this is all I learned. Okay, but nonetheless, you've got this basic idea you can do with this. Okay, so it just allows you to take the log of both sides. That's all that's going on here. So if I give you another exponential equation, example 12 equals 7 times 2 to the power of x. Okay, so I've got this one here. Okay? Now, we know that we'd have to divide by the 7, okay, because we can't put these together. By BEDMAS, and we talked about this before, by the order of operations, I have to do this exponent before I do the multiplication. Since I can't do the exponent, I can't do the multiplication. So I'm going to say, well, let's undo that. Let's divide by 7. So what I'm going to end up with is 12/7 equals 2 to the power of x. Now, I could do the conversion. Alternatively, I'm going to take the log of both sides. So it's going to be the log of 12/7. Okay, put that in brackets. The log of 12/7, which is equal to the log of 2 to the power of x. Okay. Then from there, well, that x can come down in front. So I'm going to have the log of 12/7 equals x times the log of 2. Then from there, I'm going to divide by the log of 2. And the reason I divide by the log of 2 is because it's x times the log of 2, so I want to get that over to the other side. So I'm going to get x on one side, and it's going to be the log of 12/7 divided by the log of 2. There's my exact solution. Okay. I could go in and type that into the calculator, and I'm just going to do it just for fun, but I'm not going to write it. So I could say it's the log of 12/7 divided by the log of 2, and that's going to be 0.77760757787, etc., etc. So I can do it that way. So it's just solving with the log of both sides, taking the log of both sides. And I'm using log base 10 because that's what the calculator does. Okay, it's no real great reason beyond that. So if I look at an equation like this, okay, e.g., this is only a spot where it gets a little harder. If I say 29 equals 3 times 2 to the power of 4x minus 1, okay? In this case here, this is just getting harder. Now the coefficient is still the problem, so I'm going to divide the coefficient off. So I'm going to get 29/3 equals 2 to the power of 4x minus 1. Okay? From there, I'm going to take the log of both sides. So it's going to be the log of 29/3 equals the log of 2 to the power of 4x minus 1. Okay. Now if I've got a binomial as an exponent, this is where it gets a little bit more complicated. Because watch what's happening. I get the log of 29/3. I'm bringing the entire exponent down. The entire exponent was 4x minus 1. And it is the entire exponent times the log of 2. So I need to remember the brackets around here, okay, because it's the entire exponent times that. So the entire exponent times that, remember the brackets. Now from here, I'm trying to solve for x. So that log 2 is in the wrong side. It was multiplied, so I'm going to divide it. So if I divide by the log of 2, those cancel. But whatever I do to one side, I got to do to the other. So I'm dividing by the log of 2. So what I'm going to end up with is the log of 29/3 divided by the log of 2 equals 4x minus 1. Okay. Now to solve for x, I would add the 1 over. So I'm going to get the log of 29/3 divided by the log of 2. Add the 1, and that equals 4x. Okay? And then you say, well, I'm wanting to solve for x. So I divide by 4. So I'm going to get, and this just gets confusing to look at, the log of 29/3 divided by the log of 2 plus 1 all divided by 4 equals x. That is my answer. Now that's the exact form, and I'm going to write exact this time. I could type it into my calculator. The problem is typing it into the calculator is a little bit complicated to do it one shot. So I'd probably do it in two or three different steps. So I'd go into my calculator, clear out what's there. First thing I'd do is the log of 29/3 divided by the log of 2. Okay, I'd figure that out. Then I'd add 1 to it. Once I get that, then I'd divide it by 4. And it's 1.068. Now, that's what you'd get solving it the other way as well. Okay, I would never try to type this in one shot, because you have to remember so many different sets of brackets that it ends up getting confusing just to remember brackets. So type it in series, go from there. This is solving an exponential equation a different way, solving it by taking the log of both sides. You can do this, and if you like this, do this. That's just a different solution. So the homework is going to be solving exponential equations again, but doing it by taking the log of both sides, just to make sure that you can do it. If you have any questions, please let me know, and I'll see you in class. Thank you.